Hello, Assalamu alaikum, all viewers and dear students and ladies and gentlemen. Once again, Maqbool Islam is in front of you. Today we are focusing on the theorems from the all boards of any country. So the theorem is related about the chords. So first of all, we write the name of the theorem. Theorem if two chords of a circle are equidistant from the center of a circle, then they will be if two chords of a circle are congruent, and here is if we used congruent from the center of the circle, then they will be equidistant from the center of a circle. We will prove the statements. If two chords of a circle are congruent from the center of a circle, then they will be equidistant from the center of a circle. Look here. So from the condition if is used for the given and then is used for the to prove it. Now there are two statements. If two chords of a circle are congruent, it means that given is already given that. So now first of all, then we write or draw a circles. We draw a circle from the center O. And here two chords are required. So these are the required. A and B are any two chords. And another chords we are drawing. So we are using here CD. CD is another chord. A, B and CD are any two chords from the center of the circle. So we want to prove that then they will be equidistant from their centers. Now first of all we write according to the condition given. If is used from the if is used, then we write the given. We take a circle with center O and here AB and CD are any two chords from the center of a circle. And they are congruent. So we write that is AB is congruent to CD. or we can say that measurement AB as equal to measurement CD. That is the statement already given if the two chords of a circle are congruent. So this is given. Now we want to prove that then there will be equidistance from the centers. That means that we draw here one of the perpendicular lines and another is from the same center. This is the centers E and F. E is the midpoint of AB and F is the midpoint of CD. And OF is perpendicular on the chord CD and OE is perpendicular on chord AB. But we want to prove that these perpendiculars are the same from the equidistance from the center of the circles. Then we want to prove it to prove. We are using here from then means that here AB, the chord, two chords AB and CD are equidistant from the center O. We want to prove that. Now construction is required because we have already extracting OE as the right bisector perpendicular from the two chords. We draw two perpendiculars OE on AB chord and OF on CD. That is OE as perpendicular to AB and OF is perpendicular to CD. Here OE line is perpendicular to AB chord and OF is perpendicular to CD. Now joint, that is called radii, and similarly we join to OC. Joint O to A and C. That means that we can also write that measurement OE as perpendicular to measurement OF. We can also write to prove, and also we can write this statement also. Now we are to proceeding to prove. How we will prove it? Statement, statements and reasons. Now we can write according to the definition of perpendicular. Look here, the chord AB, for example, this is the center and AB is the chord and E is the midpoint of. Similarly, the same line you can write here O is the center and CD is the chord and F is the midpoint. We want to prove that according to the perpendicular condition here OE is perpendicular to AB, and similarly OF is perpendicular on CD. So that is, we have already discussed. And construction. Construction means that we have already suppositions. Now, if this line is perpendicular on AB, it means that we can write AE is congruent to EB. AE is congruent to AB, or we can say that BE. Both are same. Similarly, we can write OF, CF line is perpendicular to FD, or we can say that DF. So, or we can write measurement AE is congruent to measurement BE, and measurement CF is congruent measurement DF. So this is the definition of perpendicular drawn, perpendiculars drawn from the center of a circle and a chord bisect it. We can use the definition of perpendicular drawn we have already discussed, and theorem number 9.3. So if this line, if we are, it means that this lines we can write AE, any AB we can write AB statement, we can write AE plus AB, or we can say that BE. So this is the postulates of additions. We can write AB is equal to AE plus AB. Similarly, CD line we can write CF plus FD, or we can say that DF. Now AB line, if we write measurement AB, right, we can say that measurement AE plus AE, AE plus measurement EB. Similarly, CD measurement, CD lines we can represent measurement CF plus measurement DF according to the segment addition postulates. Segment addition postulate, we can say that, and here we have already discussed measurement AE is equal to measurement BE, and measurement CF is equal to measurement DF. From the above statement, we can write, we put the result of this one, measurement AE plus measurement in the place of EB, we put an AE, measurement AE plus, and here measurement CF plus measurement in the place of DF we put CF. Measurement CF we already discussed here this one. Now if we add this one measurement 2AE, because the coefficient of the this one is 8 2ME. Similarly, adding the coefficient of both, so we get 2 measurement of CF. Dividing both sides by 2. Here we can write dividing both sides by 2. Then we will get measurement AE, and dividing both sides by 2 measurement CF. Both are cancelled and here are also cancelled. We get measurement AE as equal to measurement CF. We give equation number first. Now similarly we can also prove that the another postulates of this one, if we put in replace of CF, put, so we will get result measurement EB is equal to measurement DF according to the given condition if we are applying. Now the comparison of the two triangles we get here after the perpendicular conditions. Here this one is the two triangles and here is the another triangle we get here this one. The comparison of this one is two triangles comparing and triangle AOA, yeah, or we can say that AOE one to one corresponding C triangle COF one to one correspondings. One to one correspondings. And here, look here, we can write here AO is congruent to CO. So that will be radii of the same circle. Similarly, we can write angle AEO is congruent angle CFO. So this will be right angle. Right angle means 90 degree because this will be represent 90 degree and here is also represent 90 degree. Or we can say that measurement angle E is congruent measurement angle F. So each is the right angle. Now, so OE is congruent to OF. Corresponding side of congruent triangles. Corresponding sides of congruent triangles. It means that we can write triangles, both condition are applied. So triangle COF, side angle by side postulates. Because we have two sides discussed and one angle, for this purpose we are using side angle by side postulates. It means that so measurement AE is congruent to CF. We have already corresponding side of congruent triangles. It is already proved an equation from equation number first. Equation number first we have already discussed here. R measurement AE is equal to measurement CF, which is proved in equation number first. So if they are congruent, they are approximately equal. So we can say that A and B, therefore we can say that OE is congruent to OF, which is perpendicular, and hence from if they are perpendicular, so on the chords AB, it means that E is the midpoint of E is the midpoint of chord AB, and F is the midpoint of CD. So AB, the chord AB and CD are equidistance from the center of a circle. This is very important theorem. If two chords of a circle are congruent, then they will be equidistant. How we can prove that? Logically, we have already discussed AB is the chord and CD is the chord, and OE is perpendicular on the chord AB and OF is perpendicular chord CD. We have already used the definition of perpendicular and also segment postulates. So we have already proved that one. Thank you very much for watching. Inshallah, the next video will be coming soon according to the topic of related topic of theorems, step by steps. Once again, please subscribe my channel. Thank you very much. Viewers, Assalamu alaikum. Maqbool Islam is once again in front of you. Today I am delivered about the lecture theorems for the class 10th. The first theorem we start. One and only one circle can pass through three non-collinear points. Theorems 9.1. One and only one circle can pass three non-collinear points. Three non-collinear points. First of all, we understand what is collinear points and what is the difference between non-collinear points. First of all, I explain what is collinear points. Collinear points are those type of points which lies on the same line. Just like we can say that here A, B, C and also D. Here A, B, C and D are lies on the same straight line, so this will be called collinear points. Now if we change the collinear points into non-collinear points, so we change, for example, we write in the triangle form, so A, B, C, so these are the non-collinear points. Similarly, if we write in the circle form, for example, here A, B, C and D are all A, B, C and D are the non-collinear point which cannot pass on the same straight line, so that will be called non-collinear points. So, and the theorem is asking from you three non-collinear points, just only one circle. Only one circle we can draw, and given that, given, we write the statement from the above statement. First of all, we draw the circle. So look here, here is, we can write, for example, O is the center. We draw a circle, and here three points are required, three non-collinear points. We write here A, B and C. We can also give the name PQR, LMN. This is your choice. Now we here A, B and C are 3 points. We write the given statement, and here we take a circle with center O. Here A, B and C are 3 non-collinear points. Now we want to the given statement to prove that this one, to prove that, to prove here the given above statement we write, it means that A, B, C are the 3 points just passes on only one circle. So we can write the given 3 points, yeah, just one and only one circle can pass 3 non-collinear points. These are points are A, B and C. Now we are required, construction is required, so we take here compass is, we are drawing perpendicular bisections on the construction. First of all, we take the compass according to your own choice, open it. So we first we take here from A center and draw an arc, and similarly we draw an arc from the outside the circle, and here also we can draw, and here, and also we can draw in here, and we connect this one perpendicular bisectors. And similarly from the B sides, if we draw perpendicular right bisectors are here, and similarly from here, and also from the internally we draw the two arcs, and these arcs we are connect just like from this ones from here. Now these two bisectors, for example, here we give the name, and here X and Y, and LM. These are the two bisector, right bisector, which intersect each other at point, the center, fixed point O. Now also we draw the chords of the circles. These are the two chords AB and BC. Joint, these are the construction we are required. And OA, OB and OC are the radius of the circle. And here we give the name A, B, C, D and E. Here D is the midpoint of AB and E is the midpoint of BC. These are the construction we write to constructions. Draw, we draw. If you are explained, then we are taking first of all, we take a center A and B. We draw two right bisector internally and externally. These are connects to each other. Yeah, just to be simple, we draw two right bisectors, two perpendicular bisectors, X, Y, X, Y, and LM. These are the two right bisectors. We draw two perpendicular bisectors XY and LM to bisect the chord AB at point D. Here AB is the chord of the circle, and similarly the chord BC, similarly the chord BC intersect या cuts at point E. Joint O to A, B and C. We get two triangles here, OAD and OBD. Similarly, if we compare OBE and OCE, these are the comparison for the proof we will do here. Proof. Statements and reasons. Look here, we are required the comparison of these two triangles. Triangle and another triangle OBD. Now, and triangle OAD, one to one correspondings. That means that the comparison to each other of the triangles O triangle OBD, and the reason we can write one to one correspondings. And here, look here, from the both triangles we get here OD is congruent to OD, means that OD is common. Similarly, this is OD. This is the right bisector. It means that we can write here 1 and 2, give the name 1 and 2. We can write measurement angle 1 is also congruent measurement angle 2. Each is right angle, means that it's 90 degree, or we can say that here measurement, and if we put measurement, so this will be changed the congruency as inequality. So measurement angle 1 is equal to measurement angle 2. So we can write measurement angle ODA, measurement angle ODA, because the angle must be between of the two figures, and it will be equal to measurement angle ODB. So we can write the same statement, each is in right angles. Similarly, here we can write AD as congruent to BD, corresponding side of congruent triangles, corresponding sides of congruent triangles, or we can say that here D is the midpoint of here D is the midpoint of AB, that is called chord. Now another points we can OS and OB, that is called radius. OA is congruent to OB, congruent side of triangle, or we can say that radii of the same center, radii of the triangle, congruent triangles. So it means that we write measurement OA is equal to measurement OB. So from the above discussion, we have already discussed one side, one angles, and another side AD and BD. From the above statements, so we can say that the triangle OAD is congruent to triangle OBD. Side angle by sides postulates. Side angle by side postulates according to the definition of side angle by side postulates. So from this one we can say that measurement OA is equal to measurement OB. This statement is also we write from here. So equation number first. Now the second triangle we are compare to each other, OBE similarly, and OBE and OCE. OBE and triangle OBE is 1 to 1 correspondings triangle OCE. 1 to 1 correspondings. Here OE, this line OE is the common points. Common is congruent to OE. Common, and here we give the name of this right bisectors also 3 and 4. Now measurement angle 3 is equal to measurement angle 4. Each is right angle and its equal be 90 degree. Or we can say that measurement angle OEB is equal to measurement angle OEC. Each is right angle. We can also write the above angles. Now we are compare the sides BE and C is congruent. The side BE is congruent CE. Corresponding side of corresponding sides of congruent triangles, or we can say that here E is the midpoint of BC, that is equal to chord. Now it means that here we can write OB is congruent to OC. So the sides BE and OE is common and one angle is common. So from the above discussion we can say that triangle OB is congruent to triangle OCE. Side angle by side postulates. So we can write now it means that here the radius OB is congruent to OC. That is, we can write also radii, or we can say the corresponding side of congruent triangle, or we can say that radii of the same circle. Same circle, just one circle we have already drawn. Now, or we can say that measurement OB is equal to measurement OC. Give the name equation number second. So from equation number first and second we can apply the transitive property because measurement OB is taking common. From according to the transitive property, we can write here from equation number first and second to get measurement OA is equal to measurement OB is equal to measurement OC transitive property. Transitive property used. So here we can write OA as congruent to OB as congruent to OC. It means that we conclude that here one and only one circle can pass through the three non-collinear points from the fixed point O. It's verified. Thank you very much for watching once again. Inshallah, step by step we will go and try step by step each theorem. Please subscribe my channels and pray for me. Thanks once again.